Okay, let's solve the question. Length of the longest V-shaped diagonal segment. Let's see what this question says. And you are given an integer matrix grid of size n cross n, where each element is either 0, 1 or 2. Let me write down all the points here. We only have 0, 1 or 2. And a V-shaped diagonal segment is defined as, first point is the segment starts with 1. That is, it should start with 1. With 1, right? Then the next point is the subsequent elements follow the infinite sequence 2 0 2 0 2 0 so on. So first element is 1. After that we need to have 2 0 2 0 and so on. And the segment start along the diagonal direction. It is top left to bottom right to top right to bottom left to top right. What this is? You can see this diagram. First we started with 1, right? Now I can move in this direction, this direction, this direction, or this direction. These are the 4 directions that you can follow here. Now continue the sequence in same diagonal direction. So we have 4 directions, right? This one, let's say, and this one, and this one. So after selecting 1, we need to choose any one of these. Choose any one direction. And we need to continue in same direction here. But make at most one clockwise 90-degree turn to another diagonal while maintaining the sequence. So we need to still maintain the sequence, but we can make at most one turn, that is to clockwise 90 degree. What this is, let me write down with the proper example. See, so I'll mark this as 0. First direction is this one, that is moving this, right? And let's say 1 is this one. Let me write this. Okay, let's say 2 is going this direction, and third one is this direction. So these are the 4 directions, right? So let's understand what this last point says clearly. At most one clockwise 90-degree turn. What is the 90-degree turn to this direction? Clockwise is like this, right? So 90-degree will be this direction. So it will become this direction. See, imagine I was moving from 1 in this direction, and if I want to make a turn, means it will go this direction. So what is this? Out of 0, 1, 2 and 3. This is first, right? I'll mark this as first. So what will happen to this direction when I move to 90-degree clockwise? This will become this. What is this one? This is nothing but third direction. Now what will happen to this? This will be moving in this direction. What is this one? This is nothing but first one. Sorry, 0th one. What will happen to third one? Last one. Last direction. Imagine we are moving this side. Clockwise means it will come this side. So this is nothing but second one. So I have mapped every direction after moving to clockwise. So now let's understand, and at last we need to return the length of the longest V-shaped diagonal segment. If no segment exists, we need to return 0. So let's understand this clearly with the example. Okay. Paste the example here. Yeah. See here, which and all elements we can start with. As I said before, we need to start with 1, right? To start with 1. So where and all I have 1 here. I have 1 here. Then these two can be the starting point, and this can be the starting point. Anyone? No, nothing else is. After that, we need to follow 2 0 2 0 and so on. The sequence. Only one turn we can make. One clockwise 90-degree turn. Turn. So let's start with the first one here. That is this one. So I can move in 4 directions, right? First this one, this, and this side, and this side. So I need to choose any one out of 4 and move along that. After that, I can make one clockwise, maximum one clockwise turn, that is 90-degree clockwise turn. So which direction I can choose? I cannot choose this and this, right? Because nothing is there here. Nothing is there. This will only give maximum answer as 1 here. Only 1 is there. So this maximum length is only 1 for these two. So I can ignore these two. Now, what if I choose this direction? Here I have element as 0. That will make 1 0. This will also give answer as 1. So previous was also 1 1. Only I am getting 1 here in this direction. Let's choose the last direction, this side. Okay, I move to this direction. So I took 2. So now the length has become 2 because 1 2 is valid. Now again I need to move in the same direction, or I can make a turn, right? I have 2 options here. See, either I can make this turn, or I can I can go in the same direction. This will be the 90-degree clockwise turn here. So but I can't make this because 1 2 1 is not valid. 1 2 1 is not valid. See here in the question they have mentioned after the turn also we need to maintain the sequence. So this can't be the answer. So if we turn this, I'll get answer as just 2 here. So I'll go again down because this is 0 here. Next, if I go in the same direction, I'll get 0. So 1 2 0 is a valid answer because it is following the sequence 2 0. Next what I can do after moving to 0, I can move in this direction. There is nothing else. So this will return answer as 3. It was greater than previous one, right? So let's say our current maximum is 3. So what else I have option? I can turn clockwise 90 degree here, right? So this will give 2 here. So this has become 1 2 0 2 0 2 0 2. This is also valid. So I can make a clockwise turn here. And again, I need to follow in the same direction. I cannot make any more 90 degree turns because I already made one time. Here I have made a turn. I cannot make maximum only one times I can make a turn. So one time already I made. Now I need to move in only this direction. So again I'll move in this direction. I have found 0. This is also valid because 2 0 2 0 is following the sequence, right? So this is also valid. Now I move here. I have moved out of the matrix, so I cannot make any more turns or anything. So this has finished. This is the maximum length I can get here. 1 2 0 2 0. What is the 1 2 3 4 and 5? This V-shaped segment size is 5. Can I get more than this for any other one? Let's see. So I have checked for this. Let's mark this out. Now which one I have? Let's take this. Can I go in this direction? No, because this is 0. Can I go in this direction? Yeah, I can go in this direction, right? Now, can I go again this direction? No, it will break the sequence here. So can I make the turn? What is the turn for this direction? See, I have written here. So for this direction, I move in diagonally upwards, right? Oh, so it will be this one. So this will also not make the valid sequence. So this will only give answer as 2. So let's remove this option and let's go. This is also not possible because this one is 0. Now I have downward path. Let me write that downward path. So now my answer is 2. Can I go again down? Yes, I can go down. This will give answer as 3. 2 0 is following the sequence. Now if I'm going in this direction, what is the 90 degree turn for this? I'm going in this direction, that is 2. It will make it will give the next 90 degree clockwise turn as 1. That is the 0th direction, right? So that is moving in this direction. Can I move in this direction? No, this will make 1 2 0 1. This is also invalid. So for this also I didn't get the anything that is greater than 5. So our answer is still 5 here. So what's another one left? This one. Okay, I'll answer for this. Here nothing is there. Here also nothing is there. So answer is 1 for this. Here 0, it breaks the sequence. Here also nothing is there. So for this, the answer is just 1. And for last one, let's see. I'll take this car only. Can I move in this direction? No, only 1 I'll get answer. Can I move in this direction? Yes, I can move in this direction. I have option. Can I move in this direction? No. Can I move in this direction? Yes. So let's see with this direction first. So I got 2, right? Again, I cannot move in this direction. Can I move in? Okay, next, I can make a turn, right? What turn I can make? Here, 90 degree turn is this side. So this will give the answer as 3. Still, this is lesser than 6. So this cannot be our answer also. So again, I'll take. Can I move in this direction? What is the 90 degree turn for this? Let's see. Our 90 degree turn will be this one for this. That is, I move this side. 1 2 0. Does this follow the sequence? Yes. Now can I turn again here? No, because already I have made one turn here. Can I go? I need to move in this direction. This will go out. So this will also return as 3. So what is our maximum here? It is 5. So this will be the maximum path will be the blue colored marked one. That is this path. Here I'll go in the same direction. Then I'll make 190 degree turn. This will give this. So total length is 1 2 3 4 and 5 is the answer here. So how do we solve this? So let's make the let me write down all the points here. What we can make. So we should only start with 1, right? B. After I choose 1, I have 4 options. That is move in these directions. Let's say first direction was this. B this, let me write down this again, C this, and D this. Okay, let me make it as 0 1 2 3 only. It will be more clear. Yeah, I have written all the directions same as before here also. So 0 will become the first direction after 90 degree turn. That is, it will go like this. This same for all this as I explained before. These are the turns that we can make. Now I have out of 4 options I need to choose. These are the 90 degree turns, but after I choose 1 I have 4 options, and these are the 4 directions, and I can make a 190 degree turn, and I have any one of these options. Only one I can only wait. Only one turn I can make. as we have seen before in that example, after I select one, imagine I got a 2. From this 2, I have two options, right? One is to go in same direction or change direction. That is, make 90-degree clockwise turn. These are the two options here. See, I am having this choice here, and also I need to choose out of 4 at 4 direction at first vector. I have 4 choice here for this, and this is I need to choose I comma j such that grid of ij is 1 at starting point. With these many choices we have, this clearly indicates that we need to go with DP approach here. So what will be the recursion code here? What will be the recursion logic? Let's see. So I need to choose what will be, let's discuss all the states here. So first I need to choose I comma j, right? I comma j can be one state. And what is next? I have 4 options. Let's mark that as direction. Direction can be either 0, 1, 2, 3. Let's mark all these as directions. This 0th direction, first direction, second direction, and third direction. Now I can make at most, I need to follow the sequence, right? Sequence. That is 0, sorry, first one should be 2. Next is, sorry. Oh my god, sorry. So the first one should be 1. After that, I need to follow with 2, 0, 2, 0, and so on. So for each index, I check the previous one and I check if it is following the sequence. So for that, I need another one. Let's say previous. This will be another state. So what kind of values this can have? Either 0, 1, and 2. In that question, they are clearly given. The only elements that can be there in the grid are either 0, 1, or 2. So after this, I can make a another option is I can make a turn. Only one time I can make a turn. So I'll mark it as false if I have not done a turn yet. Now I'll make this as true if I have already made a turn. So if I have already made a turn, if it is true, I cannot again change the direction, right? So valid answer can have only one direction also without any turn. But if I have already made one turn, imagine something like this is there. Here I have made this turn. I cannot make again turn, right? So this should when this is true, I cannot make another turn because I have already made a turn before. So let me write down the states properly. So as given in the question, the n and n size of grid can be less than or equals to 500, right? So what will be the states? Let's say it will be around dp of ij, that is the indexes. Then I'll say direction. Then I'll say the previous one, and the last one is, let's say, flag or turn. I think if we take this as turn itself. So this can be maximum of 500. Let's say 501. 501. Direction is either 0, 1, 2, 3, right? So I have 4 options. Previous one is either 0, 1, or 2. I have 3 options. And turn is either 0, 1, that is size 2. So it will be 501 cross 501. That's 4 3 12, 2 2 24. So this shouldn't give any TLE. This will pass because this is invalid range. So let's discuss how to code this recursively. Okay. Let me write down again. So all my states are I, j, direction. I, j, direction. Next one is previous, and last one is our turn. Now let's define this function as which has all the states I, j, direction, previous, and turn. Let me write this base cases later. Write the base case later. For now, let's discuss what will be our choices. So first, let's say our element is 1. Now next I need to follow the sequence 2, 0, 2, 0, and so on, right? So what will be our code here? I have 2 options. Let's say one is same direction and another is change direction. Let's say both are 0, 0. When I can change direction? If and only if flag is false, right? If not a flag, I can make a change direction, or else I cannot make. So same direction will be, so current is following the sequence, so it will be 1 plus f of, I need to follow the same direction. So let's say I have dx and dy are the current directions. That is, let's define this dx and dy. How can we write this? Write this down. Okay, let's write this as direction. What will be our direction for 0? It is, we are going in this direction. That is, row is decreasing by 1 and column is also decreasing by 1, like this. So it is -1 comma -1. Next one is, first direction is this one. Column is increasing by 1, row is decreasing by 1. That is -1 and +1. Next one is this. That is, row is increasing by 1, column is decreasing by 1. That is +1 -1. And last one is, both are increasing by 1. That is +1 +1. This will be our direction. Now let's say we have change in direction. Let's say this as 0, 1, 2, 3. These are the 4 directions, right? So what will be this? This will be 1, 3, 0, 2, as we discussed before. That is for 0th index. Let's say we are moving in the 0th direction. When I change the direction, it will become first direction. So when I'm in third direction, when I'm in first direction, it will become third. 2, it will become 0. 3, it will become 2, as I discussed before. This I have explained why it is changing like that, because this will be the 90-degree clockwise turn for all. So let's say I got my dx and dy from this direction, original direction table. Because we have, let me write that code also. It will be more clear with that. We write for first same direction first. Yeah. Let's solve this. Let's clearly write this for same direction. So what if I'm moving in dir direction, right? So I get my new dx as current I plus direction of my current direction is, that is dir of 0, and my dy will be same direction of dir of 1. This way I'll get my dx and dy in same direction. What will be my, if I change, if I make a turn, it will become new direction. So I'll write that later. For same direction, what it will be? 1 plus f of I, it will be new direction, that is dx dy. Direction is not changed, so I will remain in the same direction. And my previous element will become now, that is grid of ij. This will become the previous element. This is the grid of dx comma dy is nothing but our current element, and previous element will become grid of ij. And our turn, are we flipping the turn here? No, because we are remaining in the same direction. So turn is set as false, that is same only here. Now I'll check if I have another option to change the direction, right? I'll check if I have made a turn before. No, I have not made the turn, right? So it will become, let's say I have another variable, change is nothing but 0. So I'll take change as 1 plus f of, I'll define another one here, new direction I need to define, right? So what will be my new direction here? New direction is nothing but change direction of current direction. This will give me the new direction. Let's say if my current direction was 0, so change direction, after I make a turn, it will become 1. So it will be 1. Now I need to get new nx, and equals to nx will be direction of, this will be not dir because I have changed the direction, it will be new dir of 0. And for ny, again same, it will be new dir of 1. So I have my new nx and ny, right? Now I can make the change in direction, I can get the change in direction answer. Let's say change equals to, it will be current one, 1 plus f of my new nx ny, and direction is now new direction. And previous one is same here, again grid of ij, this is same. And what will be my next one? Turn. I need to flip the turn because I have made the turn here. So yeah, as you can see here, once we turn the, initially the turn was false, right? So if it is false, I have the option to change the direction. Once it becomes true, this is not executed. That makes sure that this will be executed only once. I hope you understood the recursion logic here. Now let's move to the base cases. Let me write the base case here. Right here, base conditions. What will be my base condition? The first one is, if I go out of the grid, that is I is less than 0, j is less than 0, or I becomes greater than or equals to n, or j becomes greater than or equals to n, we return 0. And I need to maintain the sequence of 1, 2, 0, 2, 0, and so on, right? So now, for now, I'll only consider these. I'll tell you why. Okay, that is, if my previous element is equals to current element, that is, imagine you have 2, it became 2 2 or 0 0 or 1 1 like this. This is not valid, right? This is invalid. So what we do is here also we return 0. So first we are only starting from 1. So after 1 I need to have next element as 2. So I check this also. If this should be above this. So if previous is 1 and our current is, that is, grid of ij is not equals to 2 means we return 0 because it is also not following the order 1. After that I need to get 2, but this is not happening, so we return it as false. This will be our base case. Now let's move to the main function. How to start with 1? With 1. This is very simple because what we do is we just do from for I equals to 0 to n and for j equals to 0 to n, and let's say we have let's take this as maximum, let's set this as 0. Now what we do is our maximum will be max of our current maximum and it will be 1 plus f of, we do the recursion call only if our current grid of ij is equals to 1, we execute this f of ij. Current direction is, what will be our current direction? We move in all direction, right? We have 4 options now, so we need to choose for all. So what you can do here is, if our grid of ij is 1, I can look through all the directions, that is, let's say d equals to 0 to 4, whatever the length, I can go in all direction. That is, I'll take maximum equals to max of mx, and another option is 1 plus f of ij, and current direction is d. That will make sure for calculate for all 0 1 2 and 3 d, and our next state is previous element. Previous element is 1 here. We consider 1, our current answer is 1, and then we move to next one, that is search for 2020 sequence. That will be done by this function, recursive function. Now what is the flag? We haven't made a turn yet, so our flag will be currently set to false, or let's write this as 0, and out of this we return the answer. Okay, here after we calculate new direction, that is change direction and same direction, what we need to return? We return the maximum out of, right? That is change and same direction. So this will return the maximum one, and in our main function we get the current maximum for each one. Imagine, let's say there are 1 1 1 1, some 4 ones in the grid. For each one we call this for all direction, all 4 possible directions, get the maximum from this function. This will maintain the sequence of 2 0 2 0. Since we have already started from 1, it will make sure the these will be followed. So another base condition, as I mentioned in the base condition, that if previous is 1 and current is not 2, that is grid of ij is not 2, we return 0, right? This is because when we run this one first time, imagine you had a 1 in the grid. Let's say I have 1 here. Imagine I'm moving this direction. Here, let's say we have 0. So my answer will be 1 plus f of, this will be executed. But see, here the current one is 0, right? So my previous is 1 here and current is not 2. That is, grid of ij is not 2. This is 2. So we return 0 because it is after 1, it should start with 2 0 like this. It should not. It should be starting with 2 if previous is 1. So this base condition is executed and it returns 0. So our answer is just 1 because only 1 is there. That will be the reason for this base case. Now let's discuss the time and space complexity. What is time complexity here? As I said, this is just O of n square here. We pass through all, because of memorization it will become O of n square. Now what is the space? Space complexity is, so 500 for maximum n and m, and for 4 directions, and again for the elements can be, previous elements can be either 0 1 and 2, that is just 3, and turn or not turn, that is, this is, we can say this as O of n into m into, this is nothing but 20. This will be the space. That's it for the explanation. Now let's move on to the coding part. Okay, let me solve this question, same question. Let's code this part. So let me quickly define the size, that is n is grid dot size of, and let's define column as grid dot 0 dot size. What will be next? So let me define the recursive function first, that will be more clear. So imagine we have already found 1 and we made the recursion call for f. So let me pass the grid, and grid, and and our states, as I said before, int I, int j, and our direction and previous element. And next one is, let's say, this will be the, so let me define directions also. So right here, vector int of directions. Let's say, so as I said before, we have 4 directions, that is, let's say 0, 1, 2 and 3. So what are those? As I said earlier, so for 0th direction we are moving upwards, that is top left side, right? That will be -1, -1. I'm not going to explain it much because I already put this. So next one is for 0th 1, and the next one will be 1 and -1, and the last one we move row and column both will be increased by 1. So that is 1, 1. And I need to define the change direction also. That will be for 0th direction will become 1, and first direction will become 3, the second direction will become 0, and the third direction will become 2. This will be our change direction. So now let's define the cases here. So if it goes out of bounds, right? Base. If I is less than 0, or j is less than 0, or I becomes greater than or equals to grid dot size of, or j becomes greater than or equals to grid of 0 dot size of, we return 0. That is our answer for this. Then next one is our previous element was 1 and we didn't find 2. That is, this current one is not equals to 2. That time also we return 0. Is if previous equals to 1 and grid of ij is not equals to 2, and we return 0. What is our next base case? That is, we are not following the sequence of 2 0 2 0 2 0 2 0. That is, if previous is not equals to grid of I, that is, we have found some sequence that is 1 1 or let's say 2 2 or 3 3. This is not valid, right? So we return 0 in this case also. What is our next one? That is, if grid of ij, I have started with 1 and again I found some other one. This is also not a valid sequence, right? So we return 0. So what will be my now recursion calls? That are 2 options we have, that is going same direction or change direction. Let's say, let's take this as, I'll first define the, I'll first go in the same direction. That is, I mean the same direction means my new, let's define the new points are dx and dy. So it will be I plus direction of current direction, and 0 will give me dx, and dy will be j plus directions of dir and 1. That's for dx and dy. Now what I do is I remain in the same direction. That is, let's take same direction as 1 plus f of dx dy remain in the same direction. So di will remain same, and previous is grid of I j, and after previous turn will remain same because I didn't make any turn here. So this is it for same direction. So what will be the new direction? So to change the direction, our flag should be false, right? I should not make I should not have made any turns before. So I check if not of flag, that is, I didn't make any turn. So before that, let me take another variable, int change direction as 0. Let's set this as 0. Then my new nx will be, before that I need to get my new direction. That is, new direction is nothing but change direction of current direction. That is change direction of current direction. Let's say I was at moving at 0th direction. Now I change direction, it will become 1, and new direction will be set to 1, like this. So my new nx will be I plus directions of new direction and 0, and ny will be j plus directions of new direction and 1. This will be my nx and ny. So I need to update the change direction. That will be 1 plus f of, so here I made one mistake, that is, I need to pass grid also, right? So yeah, here I pass grid, my new nx, my new ny, and direction is not now direction is now new direction. And next one is a current element, that is previous element, that will be grid of ij, and I made the turn, so I need to flip the turn. So that will be it for change direction. And at last, what we need to return the maximum one, right? So we need to return maximum of change direction and same direction. That's it for this function. Everything looks correct. So let's code the main function. So this is very simple. Let's take one variable max to keep track of the maximum V-shaped segment in our grid. So let's loop through each. Int I equals to 0, I less than n, I plus plus, int j equals to 0, j less than m, j plus plus. So I skip all the elements which are not 1. Either it can be 0 or 2, that I can't start with, so I skip it. So that is grid of ij not equals to 1. I continue, that is skipping it, or else I need to now calculate for this. So and I have 4 options: explore, all 4, direction, and keep track of the maximum. That is, say in d equals to 0, 0th direction to 3rd direction, that is less than 4, d plus plus. Let's take maximum. So let me define dx and dy. That is I plus directions of d comma 0, and dy will be j plus directions of d comma 1. So now I made the recursion call, that is maximum will be, I'll keep track of the maximum, that is maximum, and 1 plus f of pass the grid new dx and dy. Direction is d, previous element is 1, that we start with 1, and I didn't make any term yet. So this will be the recursion call. So after all this, what I need to do? I need to return the maximum. Just return maximum. So I think everything else is correct. Let me run and check if there is any error. Okay. Oh, sorry, my bad. I wrote here it as flag, so it should be everything else correct. Yep. Yep, everything is running, all the test cases. So this is exponential, right? Now I need to minimize it. So let me define the dp vector here only. Int dp equal dp will be, so see here the size is in the range 500, right? So I directly define 501, 501. So what is the size of direction? That is 0, 1, 2, 3, that is of size 4. Previous is either 0, 1 or 2, that is of size 3, and turn is either true or false, that is of size 2. So I need to set all of this to -1, right? So let me set this using a mem set. Set of dp, set as -1, and size of, okay, there's a typo, size of dp. This will set all the elements to -1. Now after I calculate this, I can set here also, that is dp of I, j, current direction 1 and 0 as maximum. Let me do the same inside this also. dp of I, j, next one is direction, previous, and that will be this. So now if it is not -1, I can just return it, right? So let me write that also, dp of I, j, previous, so turn. Okay, I missed the direction. Let me write that. Direction is not equals to -1. That is, we have already computed that before. So I can just return dp of I, j, direction, previous, and that should do the job for this dp memorization. Let's run and check. Yes, working. Let's submit and verify. Yes, working. It passed all the test cases. So yeah, that's it for the video. If you understood my explanation, please hit the subscribe button. Thank you.